In this video, I'd like to start to introduce the idea of probability. To begin with, I want to cover some important definitions. First of all, experiment. So in the context of probability, when we refer to an experiment, all this means is a well-defined procedure. For instance, we could talk about rolling a die or flipping a coin, and this is an example then of what we're going to refer to as an experiment. Once I have an experiment at hand, then we can talk about what we can refer to as the sample space. And this is also sometimes referred to as the outcome space. And this is simply the set of all possible outcomes for our particular experiment. And then finally, when I refer to an event, this is a subset of the sample space, meaning a subset of outcomes that are possible. When we talk about probability, we're going to be talking about the probability of an event occurring, and we'll see that we typically will use a capital P, and in parentheses, we'll put the name of our event. So just to make sure that some of this terminology is clear, let's consider a specific example. And that is rolling a six-sided fair die. Now, when we see the term fair in this context, the implication is that this die is not biased toward any particular face. So we would assume that the chance that it lands on a particular face is what we call equally likely among all possible faces. Now, in this instance, the experiment itself would be rolling the six-sided die. Once I have that, I can define the sample space. So one thing that we have to decide on is how we're going to represent these outcomes. So if I'm rolling a die, we expect to see a number 1 through 6. So I could use that to represent the outcomes, in which case I can write my sample space, which I'll use a capital S here, as the collection 1, 2, 3, 4, 5, or 6. And with regard to an event, there are lots of different events we could describe. So possible events, I'll point out, I'll write about them in words, and then we can identify the appropriate subset. For events, often you'll see that these are represented with capital letters from the beginning of the alphabet. So first, an event, let's call it A, is the event that you roll an even number. That tells me that I can identify A as the subset 2, 4, and 6. And we can then talk about the probability of event A occurring. And I would write that as, I said, kind of a capital P. In parentheses, I put the name of the event. And because we're assuming that these numbers are equally likely to occur, I note that I have in this subset here 3 out of my 6 total possible events. And consequently, this has a probability of 1/2 of occurring. Another possible event here, let's call it B, is the event that you roll a number strictly less than 5. Again, if I wanted to identify the appropriate subset, this would include the numbers 1, 2, 3, and 4. And finally, if I wanted to find the probability of this event, probability of B, again, I notice that there are 4 of the 6 equally likely outcomes in this subset, and consequently, the probability of B occurring is 2/3. So there are going to be some important principles of probability that we will always assume to be true, and keep in mind that this is giving our general context. So first of all, whenever we're talking about the probability of some event, it will always be true that that is a number between, inclusively, 0 and 1. So this is a good thing to keep in mind. It's very common to be able to make a math error when we're computing examples. And if I get a probability that's negative or greater than 1, then I know that I made a mistake somewhere. Another thing to consider here is that once we start talking about the probability of our outcomes, importantly, if we were to take a sum, so the term here is the probability of an outcome, and we're going to sum over all possible outcomes, then the sum of those probabilities, I should say, is equal to 1. And that's the idea that something must occur in our experiment with probability 1. And another example. So for this one, to give us a different experiment, suppose we now have a 4-sided die, and let's assume it's fair unless otherwise stated, has sides marked with the letters A, B, C, and D. And for this experiment, you're going to roll this die twice. And with that in mind, we want to look at a couple things. So first of all, A would be find the sample space. So remember, the sample space is the list of all possible outcomes. Again, I have to think of a way to represent an outcome. Before, when we talked about our 6-sided numerical die, we used numbers to represent those outcomes. Here, I can just use the letter to represent the outcome. Now, here I'm rolling it twice, so I should expect to see 2 letters. So each of my outcomes should indicate what happened on both rolls. So one way to represent this now is my sample space. I can express that I could have both rolls land on A. If I now fix on the idea of the first roll being A, of course we could get A, B, A, C, A, D. With the second roll being the first roll being B, we could see B, A, B, 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 C, B, D. I can get CA, CB, CC, CD. And then finally, we could see DA, DB, DC, or DD. So these 16 outcomes are the only possible. And with the same experiment, and now I have that sample space, I want to find the following probabilities. So essentially, I'm going to have different events that I put here, and we want to calculate the probability that they occur. So first of all, the probability that you roll 2 A's. So much like our previous example, I can assume, unless the die is stated to be biased, which it was not, I can assume that each of these 16 outcomes is equally likely to occur. So the rolling 2 A's I know is just one of my possible outcomes, so that's going to have a probability of 1/16 of occurring. The next one to consider here, what's the probability that the first roll is A? Now here, when I'm trying to think about what to look at here, I can really approach this a couple different ways. So first of all, I could look at the fact that I have exactly 4 out of these 16 possibilities that indicate that the first roll is A. Alternatively, this really doesn't involve what happened on the second roll. So you could instead focus on this as rolling the die once and thinking, what is the probability that you roll A? Either of those should lead to probability 1/4. And so that is going to be my answer here. Then if I talk about the probability that at least one roll is A. So this is a little bit more complex. Again, if I come back to my sample space here, I can consider of all of the 16 outcomes, which ones satisfy what's being described. So I'm looking for every outcome that has an A in it. So I have the same 4 that I identified in the last event, but I have more than that. So I also have BA, CA, and DA. So notice that that gives me 7 out of my 16 possible. And so again, that's going to allow me to, put this in black. say that this gives me 7 out of 16. And then finally, suppose we want to find the probability that you roll at least one A or at least one B. So this is kind of building even further from what we saw before. So again, I go back to my sample space. I want to identify, first of all, the same 7 that we saw last time, because that's still one way we can satisfy this event, that we see at least one A. But we also are allowed to consider outcomes where maybe there's not at least one A, but there's at least one B. So now I look at this, I see this would work, this, this, and this. And so if I count up the number that I've circled, I'll see that I have 12 out of my 16. So again, for this video here, I just wanted to get used to some of the terminology, see some examples where we put that into use, and then get a little bit of practice of computing the probability of certain events.